Hi students, this video is on aldehydes, ketones and carboxylic acids. As you know students, we are already done with the nomenclature of aldehydes, ketones, carboxylic acids. Not only the aliphatic saturated aldehydes, ketones and carboxylic acids but also the unsaturated ones, right? और इतना ही नहीं, we have also done with the aromatic aldehydes, ketones, the disubstituted, the trisubstituted aromatic aldehydes, ketones and carboxylic acids, structures like acetyl oxide, vanillin, phthalic acid, salicylic acid and many other difficult aldehydes, ketones and carboxylic acids are discussed. Meaning, if you remember in the nomenclature, we discussed all the questions which have come on the nomenclature in the Maharashtra board or in the NCERT board or the JEE paper or the NEET paper or the KVPY or the ISER or Maharashtra CET. All questions on nomenclature have been solved by today, not by today, in fact, yeah, today morning only was the lecture on halogen derivatives of alkanes, then on organic hydroxy compounds, that is the alcohols, phenols, ether, and on aldehydes, ketones and carboxylic acids. Now we proceed with methods of preparation of aldehydes, ketones and carboxylic acids. So let's look at the board. Here we go. The first method to prepare aldehydes, ketones or carboxylic acids is oxidation. The first method is oxidation. So oxidation of alcohols. Oxidation of alcohols. Okay. Now in the oxidation of alcohols, see, I take a primary alcohol. We know alcohols are of following types: the primary, secondary and the tertiary alcohols. The primary alcohol, the secondary alcohol and the tertiary alcohol, all the alcohols can give me carboxylic acids on oxidation. Finally, all the kinds of alcohols, primary, secondary or tertiary, can give me carboxylic acids finally. But I want aldehyde in between, I want ketone in between. फाइनली मुझे पता है ऑक्सीडेशन पे प्राइमरी अल्कोहल, सेकेंडरी अल्कोहल या टर्शियरी अल्कोहल ऑक्सीडेशन पे फाइनली कार्बोक्सिलिक एसिड देता है, लेकिन मुझे एल्डिहाइड कीटोन पे रिएक्शन को रोकना है. स्पेशली एल्डिहाइड्स पे रिएक्शन को रोकना बहुत ही डिफिकल्ट है. When we do oxidation of primary alcohols, then to stop the reaction at aldehydic stage is difficult. Let us see the reaction and then we will see why it is difficult, okay? Now I am writing the structure of the primary alcohol like this. This is the structure of the primary alcohol. You can see the alpha carbon, that is the carbon carrying the dash OH group. This is connected to only one carbon, so it is a primary carbon. So the functional group dash OH is on the 1 degree carbon, that is the primary carbon. So this alcohol is a primary alcohol. Now, we do its oxidation. So, we treat it with oxygen in presence of reagents like K2Cr2O7 and dilute H2SO4. इधर हम और भी ऑक्सीडाइजिंग एजेंट्स यूज कर सकते हैं जैसे कि अल्कलाइन KMnO4 पोटेशियम परमैंगनेट. वी कैन आल्सो मेक यूज ऑफ CrO3. Now what happens is we get like this, and a H here. Okay, this attacks the alpha H. You know this is unstable. We've learnt on one carbon, two OH groups, highly unstable. So the molecule will breaks to give water, and the product is ये पानी निकल गया, जल गया, water गया, and we get a molecule of aldehyde like this. So primary alcohol on oxidation gives aldehydes, लेकिन ये reaction इधर stop नहीं होता. This reaction doesn't stop here. The aldehyde quickly grabs another oxygen and becomes carboxylic acid. The aldehyde formed here in presence of K2Cr2O7 and dilute H2SO4 or alkaline KMnO4 or CrO3, वो aldehyde फटाक से एक oxygen लेगा और carboxylic acid बन जाएगा. Aldehydes are very prone to oxidation and they immediately give carboxylic acid. So the reaction does not stop at the aldehydic stage over here in oxidation of primary alcohol using acidified K2Cr2O7 or alkaline KMnO4 or CrO3. Then how to stop it? The moment aldehydes are formed, they are distilled out. That is the only way to extract an aldehyde from the reaction vessel and not allow it to get oxidized to carboxylic acids. I think this much is clear. So, oxidation of aldehydes to carboxylic acids is very, very easy. And the reaction does not stop at the aldehydic stage. You know, the boiling points of aldehydes is much lower than the alcohol from which they are obtained. So to make the alcohol react, you are heating the alcohol to, a particular temperature, and in that area, aldehyde is formed and is already in the vapor state. थोड़ा भी रुके तो acid बन जाएगा. So immediately it is extracted out of the vessel. And still lower members can be prepared easily by this method using K2Cr2O7 dilute H2SO4. Once again I am repeating, lower members of aldehydes can be easily prepared by using K2Cr2O7 dilute H2SO4 or alkaline KMnO4 or CrO3. Comparatively easily, मुश्किल है काम फिर भी, क्योंकि आपको एल्डिहाइड को डिस्टिल आउट करना है, तो आपका यील्ड इफेक्ट होता है, जितना मिल सकता है उससे कम मिलता है, तो कंपैरेटिवली इजी है, लेकिन है डिफिकल्टी. तो लोअर मेंबर्स के लिए फिर भी कब कभार ये मेथड यूज हो सकता है, बट नॉट फॉर हायर मेंबर्स. सो व्हाट इज द बेटर मेथड? भाई सवाल उठता है तो करें क्या? क्वेश्चन मार्क. क्या करें? सो द आंसर इज वी कैन ऑक्सीडाइज primary alcohols to aldehyde. I am writing condensed formula of primary alcohol. It can be oxidized to aldehyde using PCC or PDC. and then we get aldehydes, and the aldehydes do not further get oxidized with PCC or PDC to carboxylic acid. What I'm saying, primary alcohol on oxidation with PCC or PDC give an aldehyde, and the aldehyde so obtained does not get further oxidized to carboxylic acid. That means PCC and PDC are the mild oxidizing agents. And now the very important thing that comes to the mind is, what is PCC and what is PDC, correct? So I'm writing here PCC and PDC over here. PCC, children, PCC is C5H5NH plus CrO3Cl minus. छोटा सा फॉर्मूला है, छोटा सा फॉर्मूला है. So C5H5NH plus CrO3Cl minus, or simply we can write like this: CrO3.C5H5 dang 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 N dot HCl. ऐसे भी याद कर सकते हो, PCC. What is the name of PCC? Pyridinium chlorochromate. क्या है इसका नाम? Pyridinium chlorochromate. So that's pyridinium chlorochromate, PCC. Okay. Next is PDC. What's PDC? PDC is, students, C5H5NH plus bracket twice Cr2O7 minus. This is the formula of PDC. अब PDC का भी नाम लिख देते हैं. PDC is pyridinium dichlorochromate. Okay, so pyridinium chlorochromate, dichlorochromate. That is pyridinium dichromate. Okay, so PCC, PDC. This is what can be used to stop the oxidation of primary alcohols to aldehydic stage. अब next हमें क्या बनाने का है? सोचो Zara socho. Let us make ketone. You want some time, you can copy it from the board, no problem at all to me. You can copy it. You can take your time. Okay. लिख लिया आप लोगों ने. Now, if you want to write an example, we can write an example. Say, I take CH3CH2OH plus O in presence of PCC or PDC to give CH3CHO plus water. और मान लेते हैं यहाँ कहीं हमने गलती से pyridinium dichromate या pyridinium chlorochromate की जगह हमने K2Cr2O7 और H2SO4 ले लिया या KMnO4 ले लिया या CrO3 ले लिया, तो जैसे ही एल्डिहाइड बनेगा उसको वेसल में से निकाल लेंगे. बिकॉज अगर छोड़ दिया तो वो एल्डिहाइड कार्बोक्सिलिक एसिड बन जाएगा. ओके, नाउ ऑक्सीडेशन ऑफ secondary alcohols. I'm writing it here. Say I take RC, R dash, OH, NH here. This is the alpha carbon. This is secondary connected to two alkyl groups. So I write here this is a secondary alcohol. This is a secondary alcohol. अब इसमें oxygen in presence of, we can use here K2Cr2O7 and dilute H2SO4. And we will avoid PCC and PDC because they are mild oxidizing agent और कीटोन का ऑक्सीडेशन डिफिकल्ट होता है. डिफिकल्ट होने की वजह से we can't use mild oxidizing agent. We want strong oxidizing agent, and that we are making use of K2Cr2O7 dilute H2SO4, KMNO4 or CrO3. Any strong oxidizing agent can be used. Still, the oxidation of secondary alcohol will stop at the ketonic stage because ketone के आगे जाने के लिए तो destructive oxidation करना पड़ेगा, तोड़फोड़ होगा. So even using K2Cr2O7 you have to apply little bit of heat. So oxidation of secondary alcohol will stop at ketone stage. Even if we use K2Cr2O7 dilute H2SO4 or we use KMNO4 or we use CrO3, we will not use PCC PDC to oxidize secondary alcohol. Okay, so our CR dash, a OH here, this O attacks here and I get a OH over here, so this is unstable. एक कार्बन पे दो OH नहीं हो सकते. So it loses the molecular water, ये गया, and we get RCR dash. Hope the board is clear. Double bond O plus water. This is ketone. We can write an example. Say I take a chhatri over here, and I take a chhatri over here, and I take a H and I take a OH plus O. So attack. So I get K2Cr2O7 and dilute H2SO4. So I'll be getting the unstable compound CH3, CCH3, OH, and OH, highly unstable, loses the molecular water, and we get CH3, C double bond O, CH3 plus water. So this is propan 2-ol. This is propanone. Propanone. So I think oxidation of alcohols is clear to everybody. The board, little bit, I'll take the board there. No, here. Yep. So propanone is formed. Okay. So that was the oxidation of primary alcohols and secondary alcohols to stop the oxidation at the aldehydic and the ketonic stage. और आपको पता है primary alcohol can also be used to make carboxylic acid. और वो भी हम लिखेंगे, लेकिन लिखेंगे कहाँ? यहीं लिखेंगे. इसको इरेज कर देते हैं. ओके, इसको इरेज कर देते हैं. यहाँ पे हमें ऑक्सीडेशन ऑफ अल्कोहल को एल्डिहाइडिक स्टेज पे नहीं रोकना है, तो हम इसको डिस्टिल आउट नहीं करेंगे. सो व्हाट विल हैपन इज दिस विल गेट अटैक्ड बाय ऑक्सीजन which K2Cr2O7 and dilute H2SO4 is producing, and this will attack here, and we will be getting RC double bond OH, that is alkanoic acid. So we can conclude primary alcohol with K2Cr2O7 and dilute H2SO4 forms carboxylic acids, and And the reaction does not stop at aldehydic stage, but aldehydes are extracted in middle only. By distillation, they are distilled out. So K2Cr2O7 and dilute H2SO4 or KMNO4 or CrO3 is not a good method to prepare aldehydes by oxidation of primary alcohols, but it is a very, very, very good method to prepare carboxylic acids. So primary alcohols on oxidation with K2Cr2O7 dilute H2SO4, alkaline KMNO4 or CrO3 gives carboxylic acid in good yield. Okay, so I hope this is clear to everyone. Now I would like to do, I'll just erase this quickly. I'll just erase this quickly, and I would like to solve 3 questions over here only. So I'll just erase it. Oxidation of alcohols, and let us do the related questions right now. That will give us a better understanding, because just now we've done this, and if we do the related questions, it'll be always better. Okay, just erase all this. In just 30 seconds, we need not much time as such. Okay, so okay, now the first question. Okay, let me see the first question. So for example, we have to, I'll just take the question, say we have to convert, just a minute, okay, the question, the identification kind, okay, a good one. The question is telling us, what it's asking is, identify A in the following. Okay, A in the following, and the question is just like this. Identify A in the following. So obviously there are more than one such question. Identify A in the following. Okay, no problem. Not this A, huh? This is question number A. Okay. It says A on oxidation gives CH3, CH, CH3, CO, CH3. Okay? We'll just solve it here later on. B. What is the next question? The next question is A on oxidation gives okay, this, and the next is next are the conversions. So this is a question. Another question is convert the following. Convert the following. So is benzyl alcohol to benzaldehyde. So benzyl alcohol to benzaldehyde. Okay, next question is cyclohexanol to cyclohexanone. Okay, B. Cyclohexanol to cyclohexanone. Next is cyclohex 2-in-1-ol to cyclohex 2-in-1-ol. Oh, nice one. Cyclohex 2-in-1-ol to cyclohex 2-in-1-ol. Okay, that's the question. Okay, now let us just solve them quickly. Now see, A on oxidation gives this. तो अपने को A पता लगाना है. किसी भी रिएक्शन में फंक्शनल ग्रुप पार्ट लेता है. किसी भी रिएक्शन में फंक्शनल ग्रुप पार्ट लेता है. किसी भी रिएक्शन में फंक्शनल ग्रुप पार्ट लेता है. तो फंक्शनल ग्रुप देखो ये है. ये फंक्शनल ग्रुप ऑक्सीडेशन से मिला है. यानी अगर इसको रिड्यूस कर दूं तो वो मिलेगा जिसके ऑक्सीडेशन से ये मिला है. वापस ज्यादा हो गया. We know in any reaction functional group takes part. This is the functional group which I obtained by oxidation of this compound. If this on oxidation gives this functional group, then the given functional group on reduction will give the starting functional group. Let's see. Carbon chain will not react. Carbon chain जैसा है वैसा लिख दिया. ये कार्बन चेन है लिख दिया. फंक्शनल ग्रुप को रिड्यूस कर दो. वो जो O है उसको एक H दे दो. रिडक्शन इज एडिशन ऑफ H. खत्म क्वेश्चन. 3 1 3 1 3 plus oxidation in presence of K2Cr2. रिएक्शन लिख के दिखाना पड़ेगा. ये नहीं बस कुछ भी करा है. ये बोर्ड क्वेश्चन में रिएक्शन लिखना पड़ेगा. हाँ, अगर ये जेई क्वेश्चन है, नीट है, कुछ नहीं, सीधा आंसर निकालो. इधर H डालो, हो गया क्वेश्चन का. इधर ही H लगा देने का. A on oxidation gives this, so this on reduction, तो इसके ग्रुप को रिड्यूस कर दो, H डाल दो. So we get this compound. Okay, plus water. अब लिख देने का नाम लिख देते हैं उसका. A is 1 2 3 and 2, so 3 methyl butan 2-ol. A is 3 methyl butan 2-ol. Okay, so I think this is quite clear to everyone. It's not difficult as such. Now this, किसी भी रिएक्शन में फंक्शनल ग्रुप पार्ट लेता है तो फंक्शनल ग्रुप पे जाओ. इस ग्रुप को रिड्यूस कर दो. ये इसको रिड्यूस करना है, कर देते हैं. कॉपी द कार्बन चेन, एंटायर कार्बन चेन. O को एक H दे दो. ये रिडक्शन हो गया तो इधर 2 H आएंगे. 3 1 2 3 PCC. No K2Cr2O7 and dilute H2O, because just now in this lecture only we have learned that if you want aldehyde in good yield, then oxidize primary alcohol using PCC or PDC. और वो क्या है यहाँ लिखा है? Oxygen. So we get CH3, CH2, CH, CHO, CH3 plus water. So we will say A is 1 2 3 4. इसको हमेशा 1 देना पड़ेगा नंबर. Aldehydes are always 1. They always get position 1. The functional group aldehyde always gets position 1. The name of the functional group is formyl group. The formyl group, which is the functional group of aldehydes, always get position 1. So 2 methyl but and al. Okay, so these are some conversions which we are doing. I hope you are understanding the lecture. New. Okay, whatever. Benzyl alcohol to benzaldehyde. I'm just making benzyl alcohol. Benzyl alcohol. This is phenyl group. This is benzyl group, and OH benzene पे चिटका हुआ नहीं है. That's why this is not a phenol, but this is alcohol. Okay. Benzyl alcohol on oxidation, aldehyde बना रहे हैं, so PCC gives benzaldehyde and a molecule of water. Now हम नाम वाम लिख देते हैं. This is always in the exam. Write the names. That's why I'm writing. Because if I'll not write, you will also not write. You are buddhiman. Benzaldehyde. Okay. Now this one. Cyclohexanol. Cyclohexanol. ये cyclohexanol. Okay. गोलू मत बना देना अंदर, नहीं तो बेंजीन बन जाएगा. 2 cyclohexanone. Plus oxidation, ketone है, you can use K2Cr. You have to use K2Cr2. You can't use PCC-PDC. K2Cr2O7 and dilute H2SO4. क्या मिलेगा? Ketone बनेगा. So cyclohexanone. नाम वाम लिख देते हैं. Cyclohexanol. Cyclohexanone. Okay. Now we go to the next one. That's this. Cyclohex 2-in-1-all. इसको थोड़ा डार्क कर देते हैं. कुछ लोगों को सस्मा है. सस्मे की वजह से दिखेगा नहीं. Okay. Now this okay. Cyclohex 2-in-1-all. ये 1 पे all लिखा, 1 2 2 पे इन लिखा. Oxidation, ketone बन रहा है, so we will be making use of K2Cr2O7 and dilute H2SO4. So we will be getting cyclohex 2-in-1-all plus a molecule of water. That's the way. Okay, अब बहुत ही काम की बात. कीटोन बन रहा है. कीटोन इज मेड विद K2Cr2O7 dilute H2SO4. लेकिन एक प्रॉब्लम है, उसे याद रखना है हमेशा, इसीलिए डायरेक्ट बताया नहीं. एंड दैट इज कहाँ गया डस्टर? ये रहा. द बेस्ट इज हियर PCC. Because K2Cr2O7 dilute H2SO4 will rupture the pi bond. और इसको रप्चर करके ये ओपन चेन कंपाउंड बना देगा. तो याद रखना PCC यूज करना है in methylene dichloride. So that is how you have to solve this. अब यहाँ एक बड़ी इंटरेस्टिंग चीज और एक मैं बता देती हूँ. वो क्या है बोलती हूँ. देखो, we can use PCC-PDC. Once again, I am repeating, PCC-PDC are the mild oxidizing agents. So they are used to convert primary alcohol to aldehyde and stop the reaction at the aldehydic stage. Okay. Now, what else can be used that I am telling you, which will be of great help to you? The very first thing, ये जो PCC है, PCC. This is also called Corey's reagent. It is also called Corey's reagent. I have given this in my notes also. You can refer, but I'll just complete certain points. It will help you. We can also make use of Collins reagent. We can make use of Collins reagent. What is Collins reagent? It is CrO3 and 2C5H5N pyridine in CH2Cl2 solvent. Okay, so that is Collins reagent. We can also make use of Jones reagent. Jones reagent is solution of CrO3 in H2SO4 in aqueous acetone. Okay, so we can use Jones reagent also. So these are some more important points on oxidation. So students, I think oxidation of primary alcohols to aldehyde using PCC PDC and primary alcohol to carboxylic acids using K2Cr2O7 dilute H2SO4 alkaline KMNO4 or CrO3 possible, and oxidation of secondary alcohol to ketone can be done using K2Cr2O7 H2SO4 alkaline KMNO4 or CrO3. So that's all in the oxidation of alcohols to prepare aldehydes, ketones and carboxylic acids. Study well. Bye-bye. Take care. Love and blessings to all of you.